Geometry section 2.4, whole bunch of properties. We're going to talk through this list and then just do a few examples that go along with this stuff. This is, again, we're laying the groundwork. We're putting the foundation in before we build the house. We got to have a language to speak before we can start writing proofs. Proofs are basically in chapters 3 and 4, and 2 is kind of the setup for that. So here goes. First of all, these first 4 properties all kind of go together. The addition property, subtraction property, multiplication property, and division property all kind of speak of something that you already know, which is whatever you do to the one side of the equation, you have to do to the other. Okay? So whatever a and b are, and they don't have to stand for just one thing. You know, if a is x squared plus 3x minus 7, and b is 2x over 3 plus 9, and I start to manipulate things so that I'm doing things to a side of the equation to try to solve this thing. Whatever I do to one side, I have to do the other. Whatever you do to the left, you have to do to the right. And this one's speaking of addition. So if a is equal to b, then a plus c is equal to b plus c. You added c to both sides. Same thing with subtraction. If they're equal, then if you subtract c from the left, you have to subtract c from the right, and they would still be equal. That's why the equal sign is kind of sometimes spoken of as kind of a fulcrum, right? The equal sign is showing that the left side is actually equal to the right side. Multiplication, same thing. Got to multiply. If you multiply both sides by c, you're still good. You still have 2 things that are equal. Division property, throw this extra thing in here where c cannot be equal to 0, and then they divide. A is divided by c, b is divided by c. The reason why c can't be 0 is because you'd get a divide by 0 error. If you've ever tried to divide something on your calculator, you know, 5 divided by 0, you got an error because you can't divide something by 0. Okay? So all that to say this, you already know that these properties work. You better already know how these properties work from previous classes. But now we want to be able to identify them by name so we know when that's happening. When you do add something to both sides, we're going to cite it, and it's going to be the addition property of equality. By the way, notice that this whole column is of equality, where this whole column is of congruence. We'll talk about that in a little bit. The reflexive property, you might think that's dumb. Yeah, of course, something's equal to itself. Let me assure you that we will use the reflexive property over and over again in proof writing. So it's one you want to know. Reflexive property, yes, something is equal to itself. A is equal to A. The symmetric property, on the other hand, is really not that important outside of this section right here. But still know it. Make sure you know it. A is equal to B implies that B is equal to A. You can just flip things around the equal sign. It should be easy to remember that way. It's symmetric. One side is like the other. A is equal to B, B is equal to A. Symmetric property. The transitive property, see if this sounds familiar to you at all. If A is equal to B and B is equal to C, then A is equal to C. Doesn't that remind you of the law of syllogism from the last section? It should. If A is equal to B and B is equal to C, then A is equal to C is the transitive property, but the origins of it were actually the law of syllogism from the previous section. Think about it like this. If I brought 3 people up in front of the class and they were all the same height, this person's as tall as this person, person number 1 is as tall as person number 2, person number 2 is the same height as person number 3, we could conclude that person number 1 is the same height as person number 3. Okay, that's the transitive property. Substitution, I hope you've seen substitution in a math class before today, and basically you're just replacing something. If A is equal to B, then B can replace A in an expression. Okay, we'll have a substitution. And then everybody knows the distributive property. Here it is, just in letter form. You basically multiply the first one by A and then the second one by A. If you got multiple terms in parentheses, they all get multiplied by that number that's out front. So A times B here, that's what you see here. And then A times C here, that's what you see here. AB plus AC. Okay, now, while these properties are important, reflexive, symmetric, transitive properties of equality, the way we're moving is towards congruence. You know that congruence means equal measure. We defined that in a previous lesson. Congruent means equal measure. 2 things are congruent if they have equal measure. Okay? So rather than saying, for example, rather than saying the measure of angle A is equal to the measure of angle A, okay? we will use congruence, and we'll say this statement, and you can leave the little measure off here and here. So these two things do say the same thing. If A is congruent to A, then the measure of angle A is equal to the measure of angle A. And I'm using a bad example for something to be equal to itself, because I should be illustrating the reflexive property. But basically, we're moving in the direction of using the language of congruence, not equals. So try to adopt the language. And yes, a segment is congruent to itself. A segment, of course, has the same measure as itself. An angle measure is congruent to itself. They have the same measure. The symmetric property, here it is as segments, and here it is as angles. Again, the symmetric property is the least important thing on this worksheet. And then finally, the transitive property, if segment AB is congruent to segment CD, and then we know that segment CD is congruent to segment EF, then we can conclude that segment AB is congruent to segment EF. Basically, here, CD is mentioned twice, so we can conclude that these two are congruent. Same thing with angles. A is congruent to B, B is congruent to C, so A is congruent to C. Here's A, here's C. Okay, so we talked through all of that so that we can now do a few examples. It says justify each step, but here's where we begin to try to train you to say what you know on the left and then justify it on the right. This is the beginnings of proof writing right here. Justify each step. Used to solve 5x minus 12 equals 32 plus x. Okay, so this is what's given. And you can just justify that with given. Okay, this is what we'll do all the time in chapters 3 and 4 with proof writing, is just justify that with the statement given. Okay, now what would you do? Most people in this situation would say subtract x from both sides. So that would give me 4x minus 12 equals 32. What did you do? You subtracted. Go ahead and cite the subtraction property of equality, and I'll show you the abbreviations that I like to use. Okay, SUBTR for subtraction. Oh, I'm sorry, I meant to mention too that I will also, like I did for 2.2, like I said for 2.2, I will put a worksheet in with the video post for section 2.4. That worksheet that we were just defining everything on, all the properties, I'll include a sheet for you that if you'd like to print it, you can have that. Okay. So anyway, from off that sheet, I'm taking the subtraction property, and this is a good abbreviation. Now, if you look down the list on that sheet, and I don't want to keep going back and forth, it would make it confusing if you abbreviated subtraction with just the first 3 letters, right? SUB. So at least do 4 letters. I've always gone 5 for subtraction. But if you just said sub property, I wouldn't know if you mean subtraction or substitution. So make sure you use at least 4 letters. You can abbreviate property with prop, and then the equals is because this is a property of equality, right? We had 2 columns, equality and congruence on that sheet. And since we're dealing with equals here, this is a property of equality. So I just put an equal sign rather than saying of equality. What would we do next? Add 12? I don't know why it does that. To annoy me, I guess. We were adding 12, so 44. You added to both sides, so how about the add prop of equality? And then finally, you would divide by 4 and get x equals 11. That was the division property. Feel free to abbreviate the way I am. Okay, so x equals 11, and these are your justifications, if you will. We will do this all the time with proof writing. This is what we can say. This is why we can say it. This is because it was given. Then we can do this because of the subtraction property. Then this because of addition property. Then finally, this x equals 11 because of the division property. Next one says, suppose points A, B, and C are collinear. That means they lie on the same line with point B between points A and C. Solve for x if AC is equal to 21, BC is equal to 15 minus x, AB is equal to 4 plus 2x. Justify each step. This is a type of problem that we would have seen in chapter 1, but now we're saying this. First of all, A, B, C, and I don't know if I've got this right. You know, it could end up that, you know, BC is shorter than AB. I don't know that at the moment. But anyway, AC is 21. This whole length here is 21. whereas BC is 15 minus x, and AC is 4 plus 2x. Okay, so here's what I would say. I would say AB plus BC is equal to AC. Okay, and I talked about this in a previous video, and I said, I said this is the segment addition postulate, and this is not important right now, but one day it will be important, and I'm going to point back to this day when we do. Well, that day is today. I am pointing back now to the time that I talked about the segment addition postulate. I also talked about it in class, but I'm not sure I talked about it in front of all 4 cohorts, but I for sure talked about it in a video. Anyway, know it now. You need to know it now. This is true because of the segment addition postulate. Okay, and maybe if you print out that little sheet that I gave you, maybe you write that one down too, because this one's not on there. All right. Now, before I go any further, if my example here were not a segment, but rather an angle, let's just say the picture looked like this. Okay, and you wrote in this spot right here, instead of what I wrote, you wrote the measure of angle CDB plus the measure of angle BDA. BDA, that's a BDA. I just can't live with myself if I leave it like that. BDA is equal to the measure of the big angle CDA. That would be legitimate, but do you think that would be the segment addition postulate? A year does not go by where I don't have someone who cites the segment addition postulate when it should have been angle addition postulate, or vice versa. Okay, we're clearly adding angles. This angle plus this angle is equal to the big angle, like this. Okay, so that's not what we have here, but if it were angles instead of segments, you would justify with what I had just written there, and you would write what I had just written there and justify it with the angle addition postulate. This one deals with segments, so it's the segment addition postulate. Moving on. AB is 4 plus 2x plus BC is 15 minus x. And they told us that AC is 21. What is it when you replace something here and replace something here and replace something here? That is the substitution property. Again, make sure that you use enough letters that I don't think it's subtraction. I always use 5 letters on these for my abbreviation. Substitution property of equality. Okay. Next, what would we do? Well, we didn't do this in the last one, but you see like terms here. 2x minus x would just be x, and 4 plus 15 would be 19. You're welcome to say combine like terms here, but what our book actually does, which is shorter, is just says simplify. Okay, and then finally you would subtract 19 from both sides. You get x equals 2. What did you do? You subtracted. That's the subtraction property of equality. Okay, again, we're trying to train you to do the left column, right column thing. Here's what we can say. Here's why we can say it. Got one more example, and then we're out of here. Name the property that justifies each statement. Name the property from the sheet that I will put into the Google Classroom post and that was on my Starboard software when we started talking about this. If x equals y and y plus 4 equals 3x, then x plus 4 equals 3x. I'm going to say the answer right now, so if you want to think about it for a minute, pause the video. This would be substitution. You see, if these two things are true, and I took x and I substituted in for y, which you're allowed to do, right? You're allowed to substitute x in for y. That's the substitution property. You'd have x plus 4 equals 3x. That's this. X plus 4 equals 3x. This is the substitution property of equality. What about the next one? X plus 4 equals 3x, then 4 equals 2x. Again, pause the video, or I'm going to say the answer here. This is subtraction. The subtraction property of equality. Why is it the subtraction property of equality? Well, what you would do here to get the variables together would be to subtract x from both sides. And you'd have 0 in this case. You'd be left with 4, and 3x minus x is 2x. 4 equals 2x is exactly what we have. One more. What about this one? Look off the sheet if you need to. What does this illustrate? If angle P is congruent to angle Q is congruent to angle R, and angle R is congruent to angle S, then angle P is congruent to angle S. This would be the transitive property. In fact, this would be the transitive property twice. Transitive property of congruence. Whereas we were talking about equality before, now we're dealing with congruent angles. You see this symbol, that means congruence. And it's actually the transitive property twice, because if P is congruent to Q and Q is congruent to R, then I could conclude that angle P is congruent to angle R, right? And then if angle P is congruent to angle R and angle R is congruent to angle S, then I could conclude that angle P is congruent to angle S, and that's what that says. So it really is the transitive property twice. That's all. Thanks for watching. Oh, I'm sorry. No, I got one more thing. Real quick. Just looking at this real quick. Here's a segment addition, right? So what would this be? Segment addition postulate. I want to do this one because this tends to be the way we ask this on the quiz and the test, is to have you fill in some blanks and not just have to do it from scratch. So if you can do it in the homework today, you'll be fine on the test. This would be substitution. What would be next? Well, you would combine like terms, right? So you would say 5x plus 1 equals 36. That's simplify, or you could say combine like terms. And then you would subtract 1 from both sides. That's a subtraction property. Verify below, that's what you would get if you subtracted 1 from both sides. And then finally, you would divide both sides by 5. That would be the division property of equality. Okay, now we're done. Thanks.